Good morning, everyone. Um, Today we're going to continue our lesson, Introduction to Waves, and part of the lesson, kind of merge it with another lesson, and this lesson is related to light waves. Okay, but we merged it because the light waves lesson is very short, and I wanted to merge them all together. So let's go to that slide. Light waves. Okay, I like that lesson. I like light waves because there's a part where we understand how we see color, and I love that fact. So light wave is a type of energy. Light is a type of energy that travels as waves as well. So you know that light travels as waves. Light is different from other kinds of waves that must travel through matter. You know that sound waves, for example, they need air, or they need liquid, or they need solid. They need a medium to travel through. They cannot travel through vacuum. They need matter. But light waves don't. Light waves can travel through space. That's why in space you can hear sound. Really? No, sorry. That's why in space you can see light. That's why the light of the sun reaches us in space. You can see light. Okay, because light waves can travel through vacuum. In space, you know, it's vacuum, it's empty. There's no matter, there's no air, there's nothing. It's empty. Okay? But light can travel through it, but sound cannot travel through space. That's the difference, okay? So light wave is a wave that does not need a medium to travel through. It can travel through vacuum. That's very important for you to know. Light can travel through vacuum. So what kind of wave is light? It's an electromagnetic wave. Okay? That means it is a wave made of two waves, two transverse wave. Electromagnetic, so that means we have the electric wave and the magnetic wave. Okay, see, this is electromagnetic. So this is the magnetic wave, and this is the electric wave. So we have electric field, magnetic field together. They make an electromagnetic wave. This is a mechanical wave. This is an electromagnetic wave. They're showing you the difference here. Okay, and electromagnetic waves, it has two fields. The fields are perpendicular to each other, if you see, and carry energy away from a charged particle. You don't have to know that part, forget about it, but you just have to know, you just have to understand that an electromagnetic wave is a wave that's made of electric field, and magnetic field. It's there in the name, electro and magnetic, both, and they are perpendicular to each other. And this is light. We have something called the electromagnetic spectrum. It's composed of many different electromagnetic waves, okay, including X-rays. Okay, you've seen X-rays. Radio waves are actually electromagnetic, microwaves, and visible light. You, as a human being, can only see visible light. That's what I mean by visible. That means we can see it. We cannot see gamma rays. We cannot see X-rays. Okay, we can see the whatever comes out of an X-ray. Okay, the diagram that comes out, but you cannot see actual X-rays. Ultraviolet, you cannot see them. Radio waves, you cannot see them. Infrared, you cannot see them. You can only see visible light, like just a small sliver of the electromagnetic waves is visible to the human eye. We're able to see only this, which contains all of the colors. Okay, so these are the electromagnetic waves. So this is some examples of the electromagnetic waves. Okay, and they differ in frequency. If you notice, there's more frequency here, there's less frequency here. Okay, so look, you have radio waves are used for communication, broadcasting, satellite. You have microwaves. They're used for cooking and communication, and also satellite, but you know them as for cooking because you actually have microwaves at home. Microwaves use part of the electromagnetic spectrum, which is the microwave. Infrared can be used for cooking, imaging, communication. Okay, visible light is vision, photography, and it's the one we can see. There's ultraviolet. It's used for security, fluorescent lamps. We have X-rays. X-rays are used for airport security and medical scanning. You know that gamma rays are used for sterilizing food. Gamma rays are very dangerous. They're used for sterilizing food and medical equipment, making them very sterile. They use in detection of cancer. So this is the electromagnetic spectrum, and this is what all these waves are used for, all these types of waves. And these types of waves are all light waves. Okay? These are all light waves. Now, this is a nice part, the light and color. You know that light, white light, okay, has all the colors of the visible spectrum. So white light includes all the colors. Okay, that's we can see here. We can put white light in here in a prism. It splits and it shows you all the colors that it's made out of. Okay. Waves in the visible range appear to us as a spectrum of colors. Each color corresponds to a certain wavelength. Okay, look at this. Red color has this wavelength. See? Look at the wavelength. Look at the violet color. It has a very short wavelength. Okay, look at the green color. So each wavelength is at a certain color. Okay? If you notice here, each wavelength has a certain color. And that's something you need to know about color and wavelength. Now, how do we see color? We see color through reflection and absorption. Okay, let me show you how. You are looking at an apple and you see red. Okay, how do you see red? You don't see red because the apple emits a color that is red. Okay, nothing emits anything. Okay, in order for you to see, there has to be light. If you are in a very, very dark room and everything is closed and you open your eyes, you cannot see. Okay, you can only see when there's light. Why? Because light hits an object, and then the light that hits an object then reflects back to your eye and you're able to see it. So let's see you're outside, you're holding a red apple. Where's the light coming from outside during the day? It's coming from the sun. The sun emits white light, which includes all the colors. Now what does the apple do? The apple absorbs all the colors except for the color red. The color red is not absorbed by the apple. The color red is reflected back to your eye, and that's how you see it. Okay, that's how you see the apple as red, because it takes all the colors, absorbs them. يعني بتمتص كل الألوان وبس بتطلع الأحمر. Only reflects red, and that's why you see it as red. Okay, let's look at this for example. You're outside, you have this this thing with all these colors. Okay, so white light goes on a red color. The red absorbs all colors, only red comes out. White light comes on the green one. Green absorbs all colors and only reflects green. Now, with the difference here from the colors and the difference from red, white, and black, how do we see white and black? White absorbs all colors and reflects all colors, and that's why you see it as white, because all colors mixed together are white. How do we see black? Okay, black absorbs all color and does not emit anything. Black only absorbs color, all of them. White does not absorb anything. White just reflects all the colors. Black absorbs everything. Okay, black بيمتص كل الألوان، مشان هيك بتشوفوا لون البلاك. White, it reflects كل الألوان, all the colors, you see? And that's why you see it as white. Okay, these are the difference between white and black. Other colors, they just absorb everything and reflect their color. So green absorbs everything and reflects green, and that's how you see green. Okay, and that's our lesson, and that's it about light and colors. All you have to know.